In this lecture, we are gonna talk about the approach of using real file data in text format over the NLP pre-processing part. For this, I'll be using NLP, word tokenization, Stopwords, word lemmatization, spacey, regular expression, and other necessary files. Let's run this file so that we can go ahead with the relevant data set. Later on, I will load this data, clean the data using the lowercase, stop word, punctuation, tokenization, then part of speech tagging, and then named entity recognition will be there. So let's see what kind of data I'm going to import in this text. So I'm going to import a BBC data which is there. So I'm going to use this read.csv, and from where I'm going to load this data set, just go back here in this library, home, and just inside this text I'll have to search bbc news.csv. So can you see this CSV file is present there, and let's upload this one. Can you see this is now showing here? Now go back to my file here. Now we'll be writing double quotes inside this bbc underscore news.csv. Let's run. Now I'm having all the rows and column of this news in my bbc underscore data. Let's print bbc underscore data dot head, and you can see these are columns are present: index number, title, published data, date, guide, link, description, everything is showing here. Okay, if I want to show the information of this data set, so you can go write bbc underscore data and information is showing in a particular scenario. What kind of non-null values are present, what is the size of his data, what is the data type, everything is present in this information. I want to see the relevant head, so I can go back here with this value. So I'm going to show the particular title of this data set and their values. Can you see this is particular title available here? Can you see this is the title and this is the relevant column here. Let's see how I can clean this data set. First and foremost, I'll have to convert into lowercase. So for this, I'll be using this titles lowercase. From this data frame, I'll be choosing this title column and will be converting into lowercase. Let's see. Yes, can you see this title column has been converted into lowercase now. Later on, I'll be removing all the stop words from the given text. So I'm going to use this, I'm going to import this NLTK and this stop word in my portal. Now I'm going to remove all the stop words using the English word. So let's run, and here you can see this is gonna import first English words. Those are already there. First, I'm going to select this lowercase column, then applying this function which is going to join and split, which is not there in this stop word set. So what is this n stop word? This is an n stop word which is consisting of all the stop words. For example, a, d, for, of. Those are not having very much information in it. For example, sometimes for or other part, for example, is, are, am. These are all the relevant words but are not very informative. So for the quick review, you can go ahead with this part and you are going to select those are not present in this set. That's how I can use I can remove all the stop words and going to display this part so that you can see this is just removed all the relevant keywords. stopwords. Can you see from this lowercase I just remove can, I, to, so just remaining refuse work. In a similar way I can remove to and other words, and this is removing is and for and others are remaining in this context. So this column is not having any relevant stopwords which is present in this keyword. Okay, now once we have created a new column without stopwords, I can remove the punctuations as well. Okay, so I'll be using the newly created column no stopword. You can see this is no stopword selected here, and from the relevant column only I'm going to remove whichever is not W. So slash W is what? This is represent for word, slash S is for representing for space. So whatever is there which is word and space will keep, and whatever is not word or not space will not be there in this new column. So therefore I will be removing all the punctuation. For example, you can see this is consisting question mark, this is consisting question mark, this is consisting comma or colons here. So we will be removing every punctuation from the given text and cleaning anyhow. Let's go ahead, let's run this part, and you can see this is not having any question mark, this is not having any colon or semicolon. Once we have imported this part, I'm going to use this punctuation tab for my tokenization. For this tokenization, I'm going to chunk the data set into small pieces. So which column I'm going to select? I'm going to select the lastly created column, which is not having a stopword, not having any punctuation. Finally, we will be creating a new column with the tokens, and clean tokens will be there, and we will be using this columns here. Okay, now I'm going to create token raw and token clean. So these will be creating new column. This code will be creating new columns. First one is the token from the title column. This is the title column, and this will be the final output. So I'm going to ingesting data here from the title and creating this column. I'm going to ingesting this data set and creating this column. So you can see no stopwords, no punctuation, no stopword, no punctuation are divided into small chunks. Set of word in a list, you can say, which is not having any stopword, not having any punctuation, and we are creating two columns in this small piece of code. Once we have created tokens in this step, I'm going to create a lemmatization part. So I'm going to import this wordnet, which is going to download certain package and perform the lemmatization part. Let's run this code, and for this lemmatization I'll be using this tokens clean lemmatization. Can you see this one is going to use? So tokens clean lemmatization is new column. Which one is the ingested data? This one is the column which we used for this. So this is input and this is the output. This is input, this is the output. Now if you look at the word here we are converting into proper dictionary format. I'm not going to perform stemming, rather I'm going to directly performing this lemmatization step, because in a previous video we have seen several differences between stemming and lemmatization. Okay, if you go down you can find this is consisting. For example, here you can see this jubilee is just converting here, this years is just converted year, section is converted here, this is also converted here. So many words might be converted into given format. Okay, so this is the benefit of lemmatization. They are not blindly chopping the words but giving root value of certain words in a dictionary format. Let's create a just our tokens. So I'm going to unpack our list, single list only, and I'm going to create this one. Now later on I'm going to create part of speech tagging for the given token. So for this I'm going to use the English Core Web SM and going to create a spacey document for our raw text, better for parts of speech tagging. So I'm going to create this NLP and going to join this token raw list, which is just created here. Okay, if you will print this token raw list, you can print this value, C, enter a new cell, print this one. Can you see this is just connecting or collecting every word in a single list. Previously they are having each sentence, each row is having different list, but here I'm just connecting every word in a single list here. This is the role of this syntax. So I'm going to comment this one and run this cell again. Now for this tokens raw list I'm going to perform this join operation. Let's extract the tokens and parts of speech tags into a data frame. So first and foremost I'm going to create two columns, token and parts of speech, so that I can see very clearly in a two different columns. Now I'm going to perform tagging operation, which is token and parts of speech value. Okay, if you want to see the frequency of the given value, you can go back here and write the same code for the top 10 value. Can you see this is showing the punctuation value? We have certain numbers, 5, 4, 3 punctuations are there, codes are there, in values are ADP values there, 2 and punctuations. These are so many different parts of speech available in my sentence. Let's find most common nouns. So for this I'll have to select common noun value, which is parts of speech tagging as noun. So many nouns are present. Let's find common words in my NER tagging. So I'm going to find this verb. So many verbs are also present there. Now I'm going to find this is the common objective. I'm going to find the common adjective here. Can you see this is showing so many adjectives are also there. In a similar way, I can extract the tokens and entities tags in our data frame. So for this, what I'll do, I'll creating a new token here. So I'm just creating a new token, 2 columns, and using this token, I'm going to perform the same part. So for this, I'm going to perform the NER, name entity recognition. So I'm going to perform this tagging operation. So let's see what kind of value we are obtaining here. We are obtaining, for example, Lisa's, person, GP, geospatial dataset, and rationing and product value, super chat, cardinals, and Russian noun pronoun. Right? Let's find the token frequency count. So I'm going to perform this group by operation so that I can see these are GP, these many of England, these many Russian, USA, and other tokens are there. Let's see most common people. So most common people in my data set is just showing here. So this is going NER tagging person, and this is going to count Queen, COVID, Rishi, Sonic, Macron, Jurgen Klopp, Emma Raducanu, and others are also present. Let's see most common places you can have. I'm going to display GP. So GP is what? Geopolitical entities. It is a named entity recognition tag used to identify locals such as cities, state, countries, which I place here. Can you see? This is showing all the GPUs, geopolitical entity. Ukraine, UK, England, Russia, India, Australia. So therefore you can find several other informations there. So this is how you can perform pre-processing task over the given CSV, given idea. For complete understanding of this pre-processing, we will be completing or performing more operation on this text. Let's see in our next video. Thank you.